Part 3 of the Introduction to C# for Novices. This session, we're going to talk about conditionals and branching. And yes, I flipped the order of the lessons. I was making the looping lesson and realized that I was using conditionals all over the place in my descriptions of how loops work. So I flipped the order, and part 3 is now going to be conditionals and branching, and part 4 will be looping. So what are conditionals? Conditionals are tests for truth. So any statement that we can ask a question, is this true or not, can be a conditional. So an example would be x less than 10. What does this really mean? It really means we're asking the question, is x less than 10? Or in a true-false statement, it might be, is it true that x is less than 10? And the answer is either going to be true or false. Each comparison has an operator associated with it. So for example, we can test for the condition of less than, is x less than 10. We can test for greater than, is x greater than 5. And we can test for equality. And you'll see that here we are using two equal signs. This is the logical test for comparison. This is saying, is y equal to value 14? Remember on the earlier lesson, when we were talking about variables, we learned that the single equal sign is the operator for set equal to or assign. So if I had y single equal sign 14, y would take on the value of 14. While in this case, with two equal signs, y is being tested to see if its current value is equal to 14. The not equal, the exclamation point equals operator means not equal to. So does y, in that example, is y equal to anything but 0? We also have the combined versions of less than or equal to and greater than or equal to. You can build these out of combinations of operators with logical ands and ors, but since it's used so often mathematically, we have an operator already for us when we combine the less than or equal to. So for example, is a less than or equal to 15.5? So let's go over to C# and see if we can do it. So let's create a logical test. So I'm going to create a couple variables here. We'll say int x equal to 15. And now I could do the logical test of, is x, let's say, is x less than 20. So how would I express that? I would express that with this statement, x less than 20. But you'll see that in C#, it doesn't quite understand what is it that I want to do with this. So what I'm going to do in my program to test out a few of these statements is I'm simply going to tell the console to write out my answer. And since the answer evaluates to a legitimate expression, a legitimate C# value, it turns out to be a Boolean value. A Boolean, remember, can take on true or false. So this phrase, x less than 20, will evaluate to a true or false statement. And as such, WriteLine knows how to write that out. So if I were to execute this program, throwing in my pause, I should see the console with a statement of truth or false here, and there it is. And you'll see that the answer, true. That statement is in fact true. Is 15 less than 20? Yes. So we could change this to a statement of, for example, is x greater than 20? And rerun our code, and we will see that it will give me a value of false. And I can also do things like, is it less than or equal to 15? And we should expect that to be true. Get that result. So there's an example of how those operators are working. How about, is x not equal to 12? So this should answer the question, should be true because x is 15 and x is not equal to 12. Again, another example. So those operators can be used and combined and are used all over the place in if conditions and loop conditions, and we'll get to all of those here shortly. Pop back over here to PowerPoint, and what happens if we have more complicated questions to ask logically than simply a single statement? Well, you can combine together these conditions in um, complex combinations using logical operators. So, for example, if I wanted to know is x less than 10 and y less than 10. So, for example, I'm writing a computer game and I want to know whether the object is in the top left corner of my window. I might have an expression similar to this. What that means is that double ampersand is just a symbol for a statement of and. So what's this asking is if x is less than 10 and y is less than 10, then the overall answer is going to be true. If x is less than 10, then it's false, and the and of a false and a true is false. So as long as each part of the expression can be evaluated as true or false, then the overall expression can also be evaluated for truth or false. So the logical operators, and what I've listed here are the short circuit versions. These are the versions I use in most cases. I tend not to embed functional changes to my values inside of logical evaluations. So short circuit operators work well for me. What I mean by that is if the first test, say for example, this in this first line, x less than 10, if x is less than 10 in a better example might be this second one. If x is not greater than 5, then there's no way for this and condition to be true because and requires all pieces to be true in order for it to work. So if the first part is false, the operation just quits and stops evaluating the rest of the expression. Those are called the short circuit versions. If you don't want a short circuit, if you want to test all the way through and evaluate all of the pieces, just use a single version of each of these. So it would be a single vertical pipe character, a single ampersand. And then the not operator can flip around the value of any logical test. So here I have the not operator outside of this y less than 5. Whatever answer y less than 5 comes back to be, true or false, the not operator will flip it to the opposite. So let's see if we can do a few examples of more complicated versions of things. So how about I write out a more complicated version? Let's give int y equals, how about 3? And now we can do some more complex tests. So if x is less than 20 and y is equal to 2, probably need one more. Let's see. I can't type. Okay, here we have a two-part expression. We have x less than 20, that's going to be evaluated true or false. Y equal to 2 is going to be evaluated true or false. And then the combination of those two will be evaluated using the and condition. So if I run this, I should expect it to give me false. And it does because y is definitely not equal to 2. So if I change this to y equals 3, this part will now be true. X is also true. True and true should give me true. If I execute that, I get true. You can see you can combine operations together. We can get complicated by adding in all sorts of levels of parentheses. So now I'm going to take that and condition, and then I can do an or, which would be vertical pipe characters, with something else, like or, I don't know, x is equal to 0.